Hello, in this video I would like to touch the basics how to solve problem 11 from homework 5.2. Let's read the problem. Coffin forces the trachea to contract, which affects the velocity v of the air through the trachea. The velocity of the air is given by the formula, where k is a constant, r is the normal radius of the trachea, and lowercase r is the radius during coughing. So you can see that the radius during coughing can reduce to 0, but cannot exceed the capital R. What radius r will produce the maximum air velocity? So how to solve it? We need to find the maximum of this function. Please pay attention that k and capital R are constants. So basically what we have here, if we open parentheses, is a cubic function. So let's go ahead and look at this function here. I copied the function again, and here I differentiated. So I differentiated using the product rule, but you also can do it by opening parentheses and take care of derivative v prime as derivative of a polynomial function. It's up to you. So we differentiated, we took derivative of this first term factor, better to say it's -1 times r squared. Then we keep the first factor and differentiate the second factor, derivative of r squared to r, and so on. And we got to the expression as here. Now, once we got this expression, now we need to find the critical numbers. To find the critical numbers, I remind you again, we need to find all zeros of this equation, or find the values of r for which derivative does not exist. But we don't have r in the places like denominator or under the square root, where the values of r will not allow a derivative v prime exist. So once you solve the equation, you get two critical numbers, r equals 0 and r equals 2 times capital R over 3. The difficulty of this, that yes, you work with a constant. It's not a fixed number. I mean, it's a fixed number, but it kind of this constant capital R is not given. So basically we need to find the maximum of the function that you see here on the left on the half open interval 0 and capital R. That's what we're going to do. And once you found the critical numbers, and this critical number 0 happened to be the edge point, you see it's left end of this interval. So we have to evaluate the function. We don't need to evaluate the function at capital R, honestly, because lowercase r is less. So but anyway, so this is the intervals we have to work on. I show you what values of lowercase r I picked, and then we compare the values of function v at r at 0. V at r at 0 is 0. And once we found the relative maximum on this interval, half open interval, and it's 2r over 3, we need to evaluate the function. We need to evaluate that function at 2 times capital R over 3. And you evaluate the function, you get the value of 4 times capital R cubed over 27 times k. Definitely it's a positive number because capital R is positive, k is a constant positive. And definitely between 0 and a positive number, you choose the positive number because it will be greater. So we can say that the function has the maximum value at r equals 2 capital R over 3, the value of function, which they didn't ask, but I just show you the value of function is 4r cubed over 27. Again, the question to the problem was what radius, lowercase r, will produce the maximum air velocity, and it's a good habit to read the question once again before you submit. So the maximum velocity will be produced with the radius 2 times capital R over 3. I hope this video was helpful, and if you have any other questions, email me please. Thank you.